video version of the slideshow for the notes on maps. Bird's eye view. What is a map? A map is a bird's eye view model of an area. Maps have been used throughout history to accurately navigate from one place to another. The science of map making is called cartography. What's wrong with this map? Well, you may have noticed that the shapes of some of the continents aren't quite right. The shapes and the sizes are a little bit off, and that's because this is an older map. So map making across centuries has improved with new technology. These days we are used to super accurate computer maps such as the ones you find on Google Maps and Google Earth. But in addition to maps of the world, we also use maps for smaller areas, such as this map of downtown Richmond. Scale. All maps have a scale. A scale is usually shown on the margin of the map. The scale is the ratio of distance on the map to actual distance on the ground. A map's scale should always be consistent. On a map of the world, 1 centimeter might equal 100 kilometers on the ground, that being a ratio of about 1 to 10 million. On a map of your neighborhood, 1 centimeter on a map might equal 1 meter on the ground, and that would be a ratio of 1 to 100. A key. Maps also usually contain a key or a legend. A key tells the meaning of symbols, colors, and lines. Every map should also have a compass that indicates cardinal directions. North N is toward the North Pole and South S is toward the South Pole. When one is facing north, west is to the left and east is to the right. If I'm ever feeling confused about west and east, I always picture a map of the United States and remember that California is on the west coast, which is the left coast. There are also directions between the cardinal directions, indicated by 2 cardinal directions listed together, such as northwest, northeast, southwest, and southeast. To get even more specific, you can use 3 letters such as north-northwest, north-northeast, south-southwest, south-southeast, west-northwest, west-southwest, east-northeast, and east-southeast. So between west and northwest is west-northwest, and between north and northwest is north-northwest, for example. So what direction is Richmond from Fredericksburg? Well, if Richmond's here and Fredericksburg's here, if you're going from Fredericksburg, that means you're starting in Fredericksburg. So Richmond is south from Fredericksburg. And what direction is Blacksburg from Roanoke? Blacksburg is to the west of Roanoke. So if it's from Roanoke, you're starting in Roanoke and you have to head west to get to Blacksburg. Map technology. Over the course of human history, maps have become more and more accurate as the technology for making them has gotten better. Today we use satellites and GPS, GPS stands for Global Positioning Systems, to make extremely accurate computer maps. And here is another example of an older map. This was considered a world map in 1459. And it's only got 3 continents. It's got Africa, Europe, and Asia, to some degree of accuracy, but not super duper accurate. Global Positioning Systems, or GPS, use 3 satellites to pinpoint an exact location on the surface of the Earth. In order to get your location, a device needs to connect to 3 satellites. This process is called triangulation. Latitude and longitude. Without GPS, it is still possible to pinpoint an exact location on a map using latitude and longitude. Latitude and longitude are like a grid system or graph paper used to define locations and directions on maps and globes. And on this globe, you can see all the latitude lines are the red lines, the flat ones, and the longitude lines are the blue ones that go up and down. So on this map, if you were looking for the latitude of Istanbul, that's about 41 degrees north. North because it's north of the equator. And about 29 degrees east. East because it's east of the prime meridian. Latitude and longitude are measured in degrees, minutes, and seconds. There are 60 minutes in a degree and 60 seconds in a minute. They are used like coordinates on a grid. Latitude is always given first with a designation of north or south. Longitude is always given second with a designation of east or west. Richmond, Virginia. The coordinates of Richmond, Virginia, the exact center of the city, are 37 degrees, 32 minutes, and 28 seconds north latitude, and 77 degrees, 26 minutes, and 5 seconds west latitude. Or longitude, sorry. Latitude first and then longitude. Latitude is north and south, longitude is east and west. Richmond is north of the equator and west of the prime meridian. The cardinal directions are given, they're very important because they designate the hemisphere. North latitude and west longitude is the northwestern hemisphere, where we live. If you switched it to the south latitude and the east longitude, those same coordinates lead to a location in the Indian Ocean rather than Richmond. So some latitudes to know. 0 degrees latitude is the equator, 90 degrees north is the North Pole, 90 degrees south is the South Pole, 23.5 degrees north is the Tropic of Cancer, 23.5 degrees south is the Tropic of Capricorn, 66 degrees north is the Arctic Circle, and 66 degrees south is the Antarctic Circle. Some longitudes to know. 0 degrees longitude is the prime meridian, and 180 degrees longitude is something called the international dateline. So the tropics, in between those two latitudes is the equator, and everything south of the Tropic of Cancer and north of the Tropic of Capricorn is considered a tropical area with warm temperatures and very little seasonal variation. Latitude lines are circles running around the globe. They're parallel to the equator, which is 0 degrees latitude, and they measure distance north or south from the equator. I think of latitude as a ladder, and it climbs from the equator to the North Pole or down to the South Pole. Latitude lines are parallel to one another, and sometimes they are called parallels. The amount of distance between lines of latitude is always the same. It's 111 kilometers. Other important lines of latitude are the Tropic of Cancer, 23.5 degrees north, and the Tropic of Capricorn, 23.5 degrees south. Longitude lines are called meridians, and they run perpendicular to the equator, and they measure distance east or west from the prime meridian, which is 0 degrees longitude. The prime meridian runs through the North Pole, the South Pole, and Greenwich, England. Longitude lines are not parallel to one another. All longitude lines run through the North and the South Pole, and as you get closer to one of the poles, the longitude lines get closer together. Therefore, the amount of distance covered between lines of longitude changes based upon your location. If you are near the poles, the distance is very short. If you are closer to the equator, the distance is longer. And you can see here how the longitude lines, they don't circle the globe, they just go from the North to the South Pole. And the closer you are to the poles, the closer those lines get together. It will be important to locate the prime meridian and equator on a globe or world map. The equator, like all lines of latitude, runs all the way around the globe, but the prime meridian only spans half of the globe, and on the opposite side of the prime meridian is called the international dateline. The international dateline is the 180th meridian, or degree of longitude, and it's called the international dateline because it's a different day on either side of it. So at the bottom of the notes, you have to find the coordinates for each letter. Letter A is at 75 degrees north, 90 degrees west. Letter B is at 60 degrees north, 120 degrees west. Letter C is at 60 degrees north, 60 degrees east. Letter D is at 15 degrees north and 45 degrees west. Letter E is at 0 degrees latitude and 150 degrees west. Letter F is at 60 degrees south and 120 degrees west. Letter G is at 30 degrees south and 0 degrees longitude, because it's on the prime meridian. Letter H is at 15 degrees south and 75 degrees east. Letter I is at 45 degrees south and 150 degrees east. So this simple concept of maps is complicated by the natural curvature of the Earth. Since our Earth is a three-dimensional oblong sphere, the translation to a two-dimensional map often distorts the shapes of bodies of land or water. Over time, people have used different projections to map the entire globe with varying levels of accuracy. The most commonly used world map projection is called the Mercator projection, which distorts the areas near the poles. There are many other examples of world map projections that distort different countries in different ways. So here's a Mercator projection. It's kind of the familiar shapes that we're used to seeing. But there's some things wrong with this map. Greenland is way too big. Canada is way too big. Africa looks smaller than it is. And another thing that's wrong with this map is that they've cut Asia in half just so that they can have the United States and North America in the middle. Here's another Mercator projection which doesn't have Asia cut in half. But you can see here near the poles everything looks too big. Greenland really isn't that big. Antarctica really isn't that big. This map's called as the McBride-Thomas projection, and it has more accurate sizes to the various countries and continents. Greenland, you can see, is a much more reasonable size, and Africa is a bigger proportionately to what it looks like on the previous projection. This one's called the Gall-Peters projection. It's supposed to be pretty accurate, but it looks kind of stretched out to me. That's mostly because I'm just used to looking at the Mercator projection. And that's the end of the notes. Thanks for listening. I will see you next time.